Welcome to the European Southern Observatory. In this video, we will introduce you to preparing MUSE observations. MUSE, the multi-unit spectroscopic explorer, is installed on the UT4 8.2-meter telescope at Paranal Observatory. MUSE is an integral field spectrograph and combines spectroscopy and imaging to make data cubes. Hence, it provides spectral information for every pixel in the field of view, covering the optical wavelength range with a mean resolving power of 3000. Hence, MUSE cubes offer a large amount of information per exposure, making it a very efficient and versatile instrument. Once your MUSE proposal is accepted, you can move to the ESO Phase 2 tool for preparing your observing material. In the Phase 2, you can define your observing blocks, or OBs, which specify the details of your observations. If you are not familiar with the Phase 2 tool, we have a dedicated video about it in this channel. You can find the link in the description. You can also use the MUSE Exposure Time Calculator, or ETC, to estimate the required exposure time to achieve your desired signal-to-noise ratio. Each OB must include an acquisition template and one or more science templates. The acquisition template ensures precise centering of the MUSE field, while the science templates are used to configure the scientific exposures. Overall, the choice of both the acquisition template and the science templates depends on the specific observing mode requested in the proposal and on the observing strategy. More details about this are given on section 5.3 of the MUSE user manual. For the science templates, MUSE offers three observing modes: the wide field mode, with or without the support of the adaptive optic facility, which we abbreviate as AO, and the narrow field mode, which always uses the AO facility. The two wide field modes provide a wide 1 square arc-minute field of view with 0.2 arc-second pixels. The wide field mode with AO covers a smaller wavelength range. This reduced wavelength range is due to a filter used to suppress contamination from the AO lasers. The wide field mode with AO also requires a tip-tilt natural guide star in the technical field of view. The narrow field mode offers higher spatial resolution over a smaller 7.4 arc-second field of view, with 0.025 arc-second pixels. It requires a tip-tilt natural guide star in the scientific field of view. In summary, the wide field modes, with or without AO, can be used to spectroscopically sample large areas of the sky efficiently, while the narrow field mode, in combination with adaptive optics, offers very high IFU spatial resolution, close to a diffraction limit. In all modes, a filter is available to cut off second-order light contamination. Each MUSE observation is divided and fed into 24 individual IFUs. By rotating the instrument by 90, 180, or 270 degrees between exposures, the patterns created by the individual IFUs can be averaged out. Hence, the combination of a small dithering pattern and 90 degrees rotations between exposures is the best strategy to reject cosmic rays and get a more uniform combined dataset in terms of noise properties. If needed, sky pointings can be added for sky subtraction. More information on best observing strategies can be found on section 5.4 of the MUSE user manual. Before finishing your Phase 2, please ensure you meet all the general and instrument-specific requirements. This includes providing finding charts, exposure times, offsets, setting the correct position angles, dithering and rotations, including a tip-tilt natural guide star when using adaptive optics, and configuring the acquisition templates. Once your OBs are reviewed and approved, your observations will be scheduled for observation at Paranal Observatory. Once the data is taken, it is immediately available for users. Automatic data reduction is performed with the official MUSE pipeline using the EDPS environment. This pipeline removes instrument signatures, calibrates the data, and combines multiple exposures into a final data cube. Reduced data is automatically placed in the ESO Archive, although both raw and reduced data are only public after the corresponding proprietary time. More information can be found in the MUSE user manual and associated online documentation. Thank you for watching. For any question, please contact us at ESO User Support. Happy observing!